Welcome to Saxon Math, Lesson 106, Starred Problems. Now, our first starred problem is problem number 2. It says to use graphing or guess and check to solve the system of equations that's given by this problem. Winifred earns $2 for each carnation bouquet she delivers and $3 for each rose bouquet. This equation shows that she earns $18. 2 times C plus 3R equals 18. The following equation shows that she delivered 8 bouquets. C plus R equals 8. Use guess and check or graphing to find the number of each type of bouquet she delivers. Now, I'm going to choose to use graphing because I don't like using guess and check. Now, graphing-wise, these are in standard form, so we're going to use our intercepts as our basis for graphing. Now, if we put in 0 for C, we'd have 3R equals 18. We would divide both sides by 3, and 18 divided by 3 is 6. If we're finding C, 3 times 0 is 0. 2C equals 18. C would have to be 9, because 2 times 9 is 18. Now, if either of these are 0, the other is 8. So we're going to have our two lines we're graphing. We would have a value of 0 and 6. We'll say this is C and this is R actually. So 0, 6 is over 0 and up 6. Nine 0 is up 0 but over 9. So 3, 6, 9. And then we'll connect these dots. Alright, and now we just need to graph 0, 8 and 8, 0. 0, 8 is going to be right here. 8, 0 is going to be right here. And we can see that the point where they cross is at 6, 2, which means they are 6 carnations and 2 roses. Our next starred problem is problem number 9. Problem number 9 says that Hector bought potted plants. He purchased 40 potted plants for $1.20 each and 60 potted plants for $1.10 each. What was the average cost he paid for his plants? Well, 40 times 1.20, you're going to have the 0 from the 0, and then you're going to need to have 4 times 0 is 0, 4 times 2 is 8, 4 times 1 is 4. There are 2 decimals, so it's 48. And then 6 times 0 is 0, 6 times 1 is 6, 6 times 1 is 6, 2 decimals, so 66. Now, 48 plus 66 is 114. 114 divided by 100 is 1.14, or $1.14. So that's his average. Now remember that the reason we divide by 100, it's 40 plus 60. It's the number of plants he bought. Alright. Question number 10 says, a cup contains 1 kidney bean, 2 green beans, 2 pinto beans, and 3 lima beans. 2 beans are removed at random without replacement. What is the probability of a lima bean and a pinto bean being removed? Well, the probability of a lima bean being removed is 3 over 1 plus 2 is 3, plus 2 is 5, plus 3 is 8. So 3 over 8. A pinto bean would be 2 over 7. Now, it's over 7 because the lima bean already got removed. And it's 2 because there are 2 pinto beans. So 3 over 8 times 2 over 7. We can factor a cross multiplication, a 1 and a 4, because 2 divided by 2 is 1, 8 divided by 2 is 4, 1 times 3 is 3, and 4 times 7 is 28. Now this was a multiple choice question, and the answer for 3 over 28 is A. Now, question 12 says that we have a lateral surface area of a cone. Now, lateral surface area is pi times the radius times the slant height. The radius is 5, the slant height is 13. 5 times 13 is 65. 65 pi can be approximated to about 204 centimeters. Question 22 says this block is built with 8 cubes. This one right here. A block with double the dimensions will require how many cubes? Well, we're going to multiply by the scale factor cubed. The scale factor in double is 2. 8 times 2 to the power of 3 is 8 times 8, which is 64 cubes. Now, we're given some information about 2 cubes. We have a large cone with a radius of 6 and a height of 10, and a small cone with a radius of 3 and a height of 5. We're told that this information will be for questions 23 to 25. Now, question A says, what is the scale factor from the large cone to the small cone? Well, to find that, all you have to do is put any dimension from the large cone over any dimension from the small cone. I'm going to use the height, so 10 over 5. 10 divided by 5 is 2, so our scale factor is 2. What is the ratio of the area of the larger cone to the smaller cone? Well, the ratio of the areas is the scale factor squared. The scale factor was 2, we found that up here in part A, and 2 squared is 4. We're then asked, what is the ratio of the volume from the large cone to the small cone? Well, the ratio of the volume is the scale factor cubed. The scale factor that we found in part A was 2, so 2 to the power of 3 is 8. Question 24 says, find A, the volume of the large cone in terms of pi, and B, the volume of the small cone in terms of pi. Now, the volume of a cone is 1/3 the radius squared times the height. The radius is 6, so 1/3 times 6 times 6 times 10. 1/3 of 6 is 2, 2 times 6 is 12, and 12 times 10 is 120. For 3, or for part B, the radius is 3, the height is 5. 1/3 of 3 is 1, times 3 is 3, times 5 is 15. Question 25 says, if the bottom 5 inches of the large cone were removed, what is the volume that remains in terms of pi for part A? Well, if we remove the bottom 5 inches, we would get a shape which looks like this. And you could notice that the bottom 5 inches would make the smaller cone. So we can actually just subtract from the larger cone's volume the small cone's volume. So 120 pi minus 15 pi would give us 105 pi. Now part B asks us to find the volume to the nearest 10 cubic inches using 3.14 for pi. So all we're going to do is take 105 and we're going to multiply by 3.14. 5 times 4 is 20. 5 times 1 plus 2 is 7. And 5 times 3 is 15. We can skip the 0 and drop 2 zeros because we're in the hundreds. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3, which was 0, 7, 9, 2, 3. And there's two digits after the decimal, so we put a decimal place right here, and 329.70 rounded to the nearest 10 is 330 cubic centimeters. All right. That will finish up problem 25. Now, make sure that you finish up the rest of your homework, stay safe, stay inside, and if you're in the morning class, make sure you come to one of the weekly meetings in order to be marked present for attendance. All right.